Students, in this video we are going to derive the confidence interval for population mean based on large sample and small sample. See, the problem is to find the lower limit and the upper limit for this population mean mu in such a way that the probability that this mu lies between the lower limit and upper limit is 1 minus alpha. That is, you must have this much level of confidence. For derivation purpose, you denote it as 1 minus alpha, and in real life it may be 0.99 or 0.98 or 0.75 or 0.90 depending on the problem under study. So you want to have this confidence interval. So this interval should have this much level of confidence. So it is called confidence interval, right? We don't have any direct method to find this confidence interval, so we seek the help of some statistic for which predefined distribution exists, right? See, we know that x bar minus mu by sigma by square root of n follows standard normal distribution, and we have studied that x bar minus mu by s divided by square root of n minus 1 follows t distribution with n minus 1 degrees of freedom when the sample size is small and when the population variance is unknown. So this follows z distribution when the sample size is large. The condition is important. S1 square by S2 square follows f distribution when the sample size is small. Ns square by chi sigma square follows chi-square distribution when the sample size is small. So these are some of the standard distributions, right? Sampling distributions which we know. Okay. Now we are going to consider one such statistic which involves the parameter mu, because the problem is to derive the confidence interval for the parameter mu. So this may suit our purpose because mu is there. This will also suit our purpose because mu is there. But here mu is not involved. Let us drop this statistic from the consideration. Here again mu is not involved. Let us drop this statistic from our consideration. Now see, we are going to use this when the sample size is large. Here the distribution is standard normal, which we know is a symmetric distribution. Alpha is the level of significance, the probability of type 1 error, and this remaining value is 1 minus alpha. We split alpha into by 2 and have it at the tails, right? So this is a symmetric distribution, so this will be minus z alpha by 2 and this value will be identified as z alpha by 2. That is the ordinate value which cuts alpha by 2 from the graph is called this z alpha by 2. Okay, so we know that even though we don't know anything about mu, we know that the probability that z lies between minus z alpha by 2 plus z alpha by 2 is 1 minus alpha. So we are going to start at this point. Similarly, when the sample size is small, see, you know that t distribution is also symmetric, so you should make use of this t ordinates. This is alpha by 2, this is alpha by 2, and this is 1 minus alpha. You know that probability that t lies between minus t alpha by 2 to plus t alpha by 2 is 1 minus alpha. Okay, so this is the idea. Now let us proceed. Now the problem is to construct the confidence interval for population mean mu based on large samples. Okay, so I know that, see, the idea is there in the graph. Since it is a large sample, probability that z lies between minus z alpha by 2 to plus z alpha by 2 is 1 minus alpha. What is that? X bar minus mu by sigma by square root of n. Yes? From this you are going to extract the confidence interval for mu. First let us multiply this minus z alpha by 2 sigma by square root of n z alpha by 2 sigma by square root of n is multiplied on both sides. Now you should retain mu at the center. Bring this x bar on either side, so it becomes minus x bar. See, you need the confidence interval for positive mu, not for negative mu. So multiply the entire inequality by minus 1. The direction of the inequality changes. It becomes plus, it becomes minus. And now change the direction of the inequality. Just reverse the inequality. Write this first. And now write this. That's all. So when 1 minus alpha is the confidence level, the confidence interval for the population mean mu based on large sample is this. Right? So this is the confidence interval for mu when the confidence level is 1 minus alpha based on large sample. Now let us come to the case of small sample. See, for small sample we are going to use t distribution. This is the statistic. So let us proceed. We know that probability of minus t alpha by 2 to plus t alpha by 2 is 1 minus alpha. Probability of minus t alpha by 2 x bar minus mu by s divided by square root of n minus 1 less than t alpha by 2 is 1 minus alpha. Probability of minus t alpha by 2 into s by square root of n minus 1 less than x bar minus mu less than plus t alpha by 2 into s by square root of n minus 1 is equal to 1 minus alpha. Probability of, bring this x bar outside, minus x bar plus t alpha by 2 into s divided by square root of n minus 1 is 1 minus alpha. Multiply by minus 1 because you want it for the positive mu. So if you multiply by minus 1, the direction of the inequality changes. Now reverse the inequality. Write this first. So you have derived the confidence interval for the population mean when the sample size is small. With the confidence level 1 minus alpha, you have the confidence interval as this, right? Okay, fine. So this is the confidence interval for mean based on large sample, and this is the confidence interval for mean based on small sample, right? Thank you.